Good morning to all. As we discussed on the last turn about the solar power, which is strongly required, or you can say the global requirement of present world, because the conventional solar power generation techniques like the solar thermal power, the thermal power, nuclear power, uh, with which we generate electric power. That is, we convert nuclear power into electric power, uh, we get electricity through hydro electric power projects, and so on. The point is, all those conventional methods with which we were getting electricity so far will end someday or other. And that's why the present scientists decide to work on the use of solar power. As I told you in the last lecture also, the sun is sending power which is equal to almost all 6,000 times the present global requirement. And sun is, you can say, a very large reservoir for in terms of energy for Earth. And sun rays which are reaching Earth are continuous. As a student of physics, I hope you understand when I say continuous spectrum means the rays starting from infrared up to visible, then ultraviolet, and then X-rays, gamma rays, and all. Of course, majority of rays falls in the visible region. That's why we are surviving on the earth. The ultraviolet rays are absorbed, as you all know, but still the power available on earth is large enough to cater our need. Now the point is how to convert this solar power into the electrical power. The simplest way of this is by the use of solar cell. The fabrication techniques of solar cell focus on the miniaturization of the device. How can we reduce the size of a solar panel? And the another aspect is how to improve the efficiency of the solar cell. We started with 1% efficiency. The first solar cell, which was developed long back, was having only 1% efficiency, conversion efficiency. Conversion efficiency means the efficiency with which it converts the solar power into the electrical power for usable purpose. So slowly and slowly, what happens? We improve over the techniques, and now scientists claim that they have the fabrication techniques. They have developed a technique with which they can prepare a solar cell up to the efficiency in the range of 35 to 40%. So that's a good sign. So the simplest method to fabricate a solar cell is by using silicon. As I told you, the first solar cell was made by the scientist Charles Fritz, who coated selenium with gold to form junction, but the cell have the efficiency 1% only. Then in the year 1984, silicon PN junction solar cell was fabricated, which has efficiency in the range of 6%. This is how the progress in the fabrication of solar cell is attained. Now, solar cell acts like a battery because it supplies DC power. It converts solar rays directly into the DC power, direct current you can say. So if you want AC, because most of the apparatus in our home are AC based, alternating current based, so you will require one inverter. Inverter means a device which will convert DC into AC. Anyway, how to get more DC by using this? So this is the basic construction uh, technique for fabrication of a solar cell. It's a simple, as I told in the last lecture also, it's very similar to the fabrication of a simple PN junction. Only thing is the band gap is tailored. I am using word tailored. Tailored means by adding the impurities, you can change the character of the PN junction because the impurities affect the current which flows during forward or reverse bias through junction. So by adjusting the band gap in such a way that the visible rays which fall on the junction can create sufficient energy for mobility of charge from one region to other, that will make possible for construction of solar cell. So uh, N-type and P-type semiconductors are sandwiched to form a simple PN junction. Surface is coated with anti-reflection coating to avoid loss of incident radiation. What we want is light which is falling on the surface of PN junction should not reflect back. So this light when absorbed creates sufficient energy which uh, is enough to move electrons or holes from one region to other, and because of which the current flows in the external load. So due to the absorption of sunlight by semiconducting materials, electrons are moved, are liberated you can say, and they produce external direct current in the external circuit. So this is how the simplest way to construct a solar cell using silicon. Silicon, as I told you, is the easily available material. So silicon based solar cells are most economic in the sense their cost economy you can say, because any device if it is not cost economic, people are not going to use it. So here we have three aspects. Scientists have three aspects in their mind. The device has to be cost effective, that is user friendly, that is uh, the efficiency is more, the size is less, uses are more, then the device will become popular. And I am happy to tell you that day by day people are moving to use solar power in their houses. More and more solar power projects are coming up, and especially in India. Earlier, the in India, the solar power generation was not popular. Now people have realized, industrialist has realized, and they have set up mega projects to generate solar power. And in our state, the leading capacity is available. Nowadays, Rajasthan is at number one in terms of generation of solar power. The most of the projects are situated in the western Rajasthan, Jodhpur district, Jaisalmer district, Bikaner district, because these are the cities where solar power availability is maximum. One thing. Other thing is the land is available, and on that land, uh, very few agricultural activity can be done because here agricultural activity is based on rain only. We call it as बरानी खेती. बरानी के अलावा कुछ भी यहाँ होता नहीं है. तो जो जमीन पंजाब या दूसरे स्टेट्स में है, जो उपजाऊ है, जो गेहूं या दूसरी फसलें साल के अंदर तीन तीन फसलें जहाँ प्रोड्यूस होती हैं, तो वहां पर इस तरह के प्रोजेक्ट लगाना कॉस्ट इफेक्टिव नहीं होता. तो इसमें दो बातें एक साथ हो जाती हैं इंडस्ट्रियलिस्ट के लिए कि उनको कम रेट के ऊपर जो लैंड है वो अवेलेबल हो जाती है, और ये एक तरह से वेस्ट लैंड मैनेजमेंट का भी एक तरह से सपोर्ट कर रहा है ये फॉर्मूला, कि जिस जमीन पे हम कोई बहुत अच्छी खेती नहीं कर पा रहे थे, वहां आज हम एक ग्रीन जो इलेक्ट्रिक पावर है वो जनरेट करने में सफल हो रहे हैं, और उसको हम ग्रिड, जो नेशनल ग्रिड सिस्टम है हमारा, उसके अंदर जोड़ने में भी सफल हो रहे हैं. डे बाय डे लोगों के अंदर भी जो सोलर पैनल्स हैं, स्पेशली रूफ टॉप के ऊपर जो लगने वाले सोलर पैनल हैं, साधारण सी भाषा में कहें तो छत के ऊपर लगने वाले जो सोलर पैनल्स हैं, उसका उपयोग या उसका चलन दिन प्रतिदिन बढ़ता जा रहा है. और जो आपका बिजली का बिल है, मैं आपकी जानकारी के लिए ये भी बता दूं कि जो आपके घरों में बिजली का बिल आता है, उसकी रिकवरी आप 2 या 3 साल के अंदर ही इस प्रोजेक्ट की कॉस्ट की जो कॉस्टिंग आती है, उसकी रिकवरी आप 2 या 3 साल के अंदर जो आप बिजली का बिल भरते हैं उससे उसके बराबर ही होती है ऑलमोस्ट ऑल. और जो भी वेंडर जिससे कि आप ये सोलर पैनल्स लगवाते हैं, वो पूरा फुली मेंटेनेंस का एक एमओयू होता है, मेमोरेंडम ऑफ अंडरस्टैंडिंग होता है, जो 10 से लेके 15-20 साल तक चलता है. तो किसी भी तरह से ये कोई किसी भी कस्टमर के लिए वन टाइम इन्वेस्टमेंट जरूर नजर आता है, परंतु लॉन्ग टर्म के अंदर उसके लिए काफी सुविधाजनक है. आपको किसी भी ग्रिड सिस्टम के ऊपर निर्भर रहने की आवश्यकता नहीं है. You are producing, able to produce on your own because sunlight is available everywhere. An important point is uh, it's nature's gift. You need not pay anything for using sunlight. That is important point. Otherwise, you need to pay for water, you need to pay for the electricity which you are getting, you need to pay for everything. But if you are using sun rays, you need not pay anything to anyone. That's the nature's gift to you. Only thing is you will have to apply it, a system through which you can convert it into the power which you can easily use. So this is the basic methodology through which we construct a solar cell. Now the problem is, if we use a single PN junction solar cell, only a few part of the solar energy is used, because here also, as you know, in photoelectric effect, the electron will be ejected only if the incident light frequency of the incident light is greater than the threshold frequency. Means the rays which have frequency less than threshold frequency will not be converted into electricity. So what scientists thought was to develop multi-junction cell. So at the same time, many frequencies were become usable with same cell. So this type of solar cell, in which instead of one junction we develop many junctions based on the band gap, and band gaps were kept in cascade manner, and that is the according to the band energy they were arranged, they were packed. And the benefit of this type of solar cell is they can use majority of solar power which is reaching on earth. So this type of solar cell we call multi-junction solar cell, tandem solar cell, various names are given, commercial names are given to it. The only point is, instead of using single PN junction, we can use many PN junctions to create a solar cell, and that solar cell will be more useful for us. This is the usual silicon base solar cell. This is the monocrystalline structure, polycrystalline structure, and amorphous silicon solar cell structure. We fabricate solar cells by using amorphous silicon. We fabricate solar cell by using polycrystalline silicon, and we fabricate solar cells by using monocrystalline. By using the three form of silicon, the efficiency is different. That's why it's useful to mention here. Silicon is same. Only thing is, if the crystalline structure is changed, even then the efficiency is changed. So this is how one can learn from this type of diagram. Monocrystalline silicon cells, they are produced from pure silicon, and the efficiency of cell depends on the purity of silicon. So monocrystalline panels indicate silicon used is single crystal silicon because the cell is composed of a single crystal, that the electrons that generate a flow of electricity is required. Polycrystalline solar panels generally have lower efficiencies than monocrystalline cells, and this is the monocrystalline cell versus the polycrystalline cell. They are made from slicing one single crystal, and this is the color aspect, expensive but more efficient. They have longer life. Polycrystalline crystals are used to fabricate. Only thing is they are less expensive, but their lifetime is small. So सस्ती चीज, सस्ता जिसको सेल कहते हैं हम, उसको बनाने के लिए इस तरह की टेक्निक का उपयोग किया जाता है। पर बहुत सारे एस्पेक्ट होते हैं जब कभी भी हम किसी सेल का चुनाव करते हैं। जो आगे और इम्प्रूव टेक्नोलॉजी है वो ये है थिन फिल्म सेल थ्योरी। थिन फिल्म सेल थ्योरी का मतलब ये है कि काम तो इसमें भी सिलिकॉन आता है, but what scientists did was a very small layer of thin film was deposited on substrate like a glass plate. The thickness of the film, you can understand, is of the order of 50 to 100 micrometer or even less than that. So a very small, very thin layer of the silicon can produce electric power from the solar power. The efficiency of monoamorphous solar cell is much lower than these two cells, and as a result lower power equipment like calculator, watch, so there they are useful. This is the final lookup: polycrystalline, monocrystalline, thin film, with the help of block diagram we can explain like this. This is the comparison. Monocrystalline silicon have efficiencies more. Of course, we have not added the thin film comparison in this table, but the efficiency and lifetime, if we consider, then monocrystalline silicon is better as compared to the other form of the silicon. Then, as I told in the earlier also, that the PV device, if we use a single junction photovoltaic cell, only photon whose energy is equal to or greater than the band gap of the cell material can free electron for an electric circuit because of the threshold frequency, existence of the threshold frequency concept, because photoelectric effect does not occur at frequency below threshold frequency. So because of that, this is the limitation. So only a portion of the sun's spectrum, sun's rays which are coming from sun to earth can be used, and that is why this type of cell are uh, less efficient in comparison to the multi-junction cell, which are also called the tandem cells. This is the setup. We use the different junctions whose band gap are, say, Eg1, Eg2 and Eg3, and this is how the power is coming, falls on Eg1, then on Eg2, then on Eg3. This is how they are arranged in the order of the band gap energy to make most of the rays useful, or most of the rays takes part in the creation of solar power. This is how they are constructed in multi-junction solar cell. Instead of silicon, we use semiconductors like this gallium, indium phosphide, and many more, germanium. So this is the anti-reflecting coating. Then we can also understand by this diagram. I think this is better. Anti-reflecting coating. Then this is the connecting grid, you can see top portion, then this is the tunnel diode, then bottom cell, and this is the substrate portion. So this is how various layers, various junctions are arranged to make use of maximum solar power which is reaching earth. This is the working, how holes and electrons moves from one region to other in a multi-junction solar cell. And thank you. So in nutshell, we say that the multi-junction solar cells are better in comparison to the simple silicon as far as efficiency is concerned, but it is not the efficiency, it is the cost, and many more things are considered on the basis of which any commercial production of solar panel is made. So these are the various techniques which people are using nowadays to create solar cell, to develop solar cell. So depending on the availability of raw material and the other aspect of the economy, one decides which type of material the company has to use to produce solar panels. Thank you.